For question 1, we want to prove that this inequality is true. Okay, so we're going to rearrange it into a quadratic that is greater than 0 and prove that that quadratic is always greater than 0. So when we rearrange this quadratic, we subtract 2 from both sides and add a half x to both sides of the inequality, and we get x squared plus 13 over 2x plus 16 is greater than 0. So we now just need to prove that this quadratic is greater than 0. Now this quadratic, we can't factorise it, so we're going to complete the square. So we've got x plus a half of our x coefficient, so 13 over 4 squared, subtract the square of 13 over 4, so subtracting 169 over 16, and then we're going to add 16 greater than 0. If we use our calculators, minus 169 over 16 plus 16 becomes plus 87 over 16. Okay, so now we need to prove that this is greater than 0. Now, x plus 13 over 4 squared is always going to be greater than or equal to 0. And we just need to write a reason why. So that is always greater than or equal to 0 because a number squared is always positive or 0. So x plus 13 over 4 squared plus 87 over 16 is greater than 0. Okay, you don't really need to write a reason here. Obviously, if we're adding a positive number to a positive number or 0, we're going to get a number greater than 0. For question 2, we're looking at the equation of a straight line. We are asked to find the equation of a straight line between these 2 points and in this form, where a, b and c are integers. Now, remember to read and reread the question when you get a coordinate geometry 1, because you will lose a mark if you do not leave it in this form, and so many people lose a mark for not doing that. So we want to find the equation of this straight line, so we're looking at using y minus y1 equals m, x minus x1, where m is the gradient. So m is the change in y over the change in x, so we've got 11 subtract negative 7 over minus 6 subtract 4, which is equal to 18 over negative 10, which is equal to negative 9 over 5. So we're going to substitute in one of our coordinates as x1, y1 into this equation. I'm going to just choose the first one. So y minus negative 7 is equal to m x subtract 4, where we've just found our value of m, that is negative 9 over 5. I'm going to multiply everything by 5 because I want to get rid of my fractions, because I want a, b and c to be integers. So we get 5y, now we're subtracting a negative 7 here, so that is actually plus 7. Plus 7 times by 5 is plus 35. That's equal to negative 9x subtract 4. Now I'm going to expand that bracket. So we get negative 9x plus 36. Okay, so when I rearrange this, I get 9x plus 5y minus 1 is equal to 0. And I would then just write down what my values are for A, B and C. A equals 9, B equals 5 and C equals -1. For part B, we are asked to find the area of the triangle OAB, where A is the point where the line meets the x-axis, so intersects the x-axis, and where B is the y-intercept. Okay, so I've drawn a little diagram of our line. Rough sketch, might not be accurate, but just to show that if we find the point A, find the point B, we're going to be doing a half times by the x-coordinate of A times by the y-coordinate of B to find the area of that triangle, because that would be a half times base times height. So, for the point A, that is when y equals 0. So we're going to substitute y equals 0 into our equation of the line. So we must have 9x subtract 1 equals 0. So x is equal to 1/9. For point B, we've got that x is equal to 0. So we're going to substitute that into our equation of the line, which we found in part A. So we've got 5y subtract 1 equals 0, and so y equals 1/5. So the area of the triangle equals a half times 1/9, which is our x-coordinate of A, and therefore the length OA. And we're timesing it by 1/5, which is our y-coordinate of point B, and therefore the height OB. So we get 1/90.